If you take the derivative of your u, you should pick up the other piece of your product a lot of times. Do you understand what I'm talking about? Like you have u be this piece, and then this other piece you get picked up by your du. Yeah? Okay? So, and then the other big idea yesterday was, okay, I get my du, and it has a constant, right? That I need, and I don't see, I don't, when I look at it, I don't see that number, right? To pick it up. Mm-hmm. So what do? You multiply by that number and also multiply by the reciprocal, because that will still be one, right? It'll still be the same thing. It just picks up the number that you need, okay? But you can only do that with constants, right? You can only do that with constants, okay? So let's take a look at this problem, okay? These next few problems. I'm going to go slow, okay? But today something new is going to happen, okay? All right. So what do you think we should let u be?
2x minus 1.
Good choice. Okay, so u equals 2x minus 1. du would be equal to 2 times dx. Okay, so looking at this, okay, I'm going to have, this right here, this little piece right here is going to become my u, right? And I'm going to have a dx here, right? But I actually need a 2 dx right here, right? Mm-hmm. So I don't have it, right? But I can put a 2 and also multiply by 1/2, right? So I'm going to start this. I'm going to do this a little bit differently than I did last period. Okay, so this is going to become equal to the integral of, that x is still there, right? The du didn't pick up that x, right? So we still have that x, square root of u times 1/2 times 2 dx. So I want to focus in. Okay, this is still right here. What is this? If I just look at that, what is that really? 1 dx, right? Or just dx. It's still this dx, right? Yeah. But this little piece right here, it's by writing it this way, it's going to allow me to rewrite this part of it as my du, okay? So where's our problem right now? It's this right here, right? We don't have a way of taking care of this x. We can't have u's and x's. It's just all going to be u's, right? Do you guys have any ideas on what that could do?
So for x,
Which one?
that u equals 2x minus 1.
Yes. I'm not worthy to be your teacher. Okay? Solve this for x. Because what can I do then? If I solve this for x, I can take that and replace this x, and it will be with u, yeah?
Yes.
That's the news thing today. Everybody okay with that? Oh my gosh, this is so hard. First period. I don't know why. Okay, so add 1. So I'm going to need to add 1 so it becomes u plus, we need to solve, let's write this, solve u equals 2x minus 1 for x. Maybe it's just first period and they were asleep still. Yeah, that's it. So it becomes u plus 1 is equal to 2x, which would mean u plus 1 divided by 2 is equal to x. I think for this situation, it's better if we write this as 1/2 times u plus 1. Because dividing by 2 and multiplying by 1/2 are really doing the same thing. So this becomes 1/2 times u plus 1 is equal to x. So back up here, this x is now going to become this 1/2 times u plus 1, right? Okay, and this was my x, right? And this part right here is going to become my du, right? That was my x. I'm just doing that to show you that that was my x, right? I replaced this x with that right there. Okay. Everybody good? Okay. All right, now, this constant right here, this 1/2, and this 1/2, I'm going to bring out in front as
1/4.
1/4. Integral of u plus 1. Instead of the square root of u to the 1/2, yeah. That 1/2 right here is gone. I pulled out in front and made the 1/4, right? And this 2 dx makes my du. And I wish I would have said this before we started, but I didn't. Okay. Up here, I want to say something. You can't like I want to multiply these out. If you can, you want to multiply these out. This is a difference under a square root, right? So you'd have to square root this, which is impossible. Okay, because of the variable here, okay? You'd have to square root it before you multiply by x. And there's no way to square root, so if there's no way to square root, you can't multiply by x, okay? In this problem, this is just distribution, right? So this is just u to a power. I can distribute that u to a power with each of these. So this one I can't multiply, but this one I can multiply, and I'd want to. Okay, now what's the power right here that's not being written?
2/2.
2/2, which is a 1, right? Okay, so this is equal to 1/4 the integral of u to the 3/2 plus u to the 1/2. And that made it a fairly simple problem to integrate, right? That's what these are going to do. When you do this, it's going to make the integration fairly simple. Okay? It's going to make it look like a problem from last unit. That's the whole idea behind it, okay? All right. So this is equal to 1/4. Okay, I'm going to put a bracket on this. Okay, and now I'm going to do my integration. Because it's 1/4 whatever that integral is, right? So I need to add 1 to this power and divide by that new power, right? So adding 1 is really adding 2/2.
Yeah.
So this becomes, so leave a little bit of space. U to the 5/2. Divide by 5/2, but a better way is to multiply by 2/5. And then plus, leave a little bit of space. U to the 3/2. Divided by 3/2, but a better way.
2/3.
Multiply by 2/3. And then plus some constant c, right? So then distributing this becomes 2/20. 2/20. 1/10. 1/10 u to the 5/2. 2/12. 1/6 u to the 3/2. 1/4 times c is still just c, right? Now, it's a different c, but it's still just a constant, right? So you just keep writing c, like it just gets absorbed into the c. You guys okay with that? Okay, so I want to say something. If you take a constant and you add another and you add a number to it, it's still a constant. It's a different constant, but it's still a constant, right? You take a constant, some number constant, right? And you subtract, it's still a constant. If you multiply a number by a constant, it's still a. So when we do all this, it just becomes, it's a different c than this. This c is a different c than this one, but it's still just a constant. It's still just a c, so we can just write c. Okay, you guys all right with that? I want to make sure that you understand these are two different c's, but it's okay. All right, nobody's gonna criticize you for not writing C1 and C2. Okay, don't do that. Okay, all right. Now we're not done yet. Why? The original question was asking you to integrate with respect to x, right? We have with respect to u, not with respect to x. But all we have to do is what? Yeah, replace all the u's with 2x minus 1, right? So this becomes 1/10 times 2x minus 1 to the 5/2 plus 1/6 times 2x minus 1 to the 3/2 plus c. You okay? Any questions at all?
That's it.
That's it? That's the answer? Yeah.
Okay.
And you guys, the only way you get good at this, and the only way you start seeing it, like, oh, if I let you be this, then it's all going to work out, right? You start seeing ahead of what you're going to do is by doing a lot of problems. Honestly, that's the only way to do it. Is like you just got to get the experience, okay? And not be afraid. At this point where you guys are at, like you picked the wrong thing to be you. Did anybody pick the wrong thing to be you last night on the homework and go, oh, crap, that's not going to help me, right? It didn't make it simpler. It made it harder. Start again and just go, okay, let's pick another you. All right?
For the like the square root, do you want to use this? Or does it just depend?
It just depends. So I don't want to say, yeah, you always do this when you see square roots. That's too, right? Kind of narrow-minded. Okay. Like you're not like it just depends. It just really depends. There has to be a function inside that square root. Yeah, it's the same. It's the same technique. So what's the difference between today and yesterday is this. This x, yesterday this x got picked up by your du. It's not today, right? You're not getting an x when you do your du. So the new thing today is, okay, how do you get that x? Well, you got to solve this u, solve it for x, that u equation, and solve it for x, and now you can take that x and replace it. That's what's new. That's the only thing that's new today. That's the only thing that's new. Okay? And you're not going to do it on every single problem. A lot of times homework are just like yesterday's.
Or like the last problems from yesterday that were just
Or just integration, you didn't have to use substitution at all. Yeah. Because we still have that, right? Don't forget, we still have that. Like if I have x plus 5 times x minus 2, that's not a u substitution problem. That's just, let's rewrite it, okay? Or this plus this over like x squared, right? You can divide each one, right, by x squared, okay? All right? Okay. But I would say yes, when you see like, okay, when you see this, I would say this is kind of a, I'm thinking I need to let u be 2 minus x, right? Because that's under a square root. So I would be thinking if you see a square root or a cube root, any root, I would be thinking, okay, let's see it's not just an x, right? I would let that be my u.
So you want us to use the one that's plugged in within a function?
Yeah.
The one that
Yeah, the thing that's inside, the problem is when there's like 3 functions, there's like 2 insides, right? There's like yesterday, you had a square, like you had a power function, right? 4th power or something. And then inside that, you had a trig function. And inside that, you had something else, right? So that's when it gets tricky. Like, what do I let u be? Do I let u be the inside of the trig function? Do I let u be the thing I'm taking the power of, right? And so it just kind of depends, all right? You let u be the angle part, right? That's inside the trig function. You let u be that and go, that doesn't give me anything. That doesn't help me at all, right? And then go, okay, cross that out. Let's try this bu. And then you go, oh, that's kind of what happens, all right? Like, oh, I pick up a bunch of stuff, okay? By picking that one being my u, all right? Okay, so let's try to let u be 2 minus x. Okay, so what would du be? -1 dx, right? Okay, so this part becomes my u. This, I need to swap this out with du, I need this to be -1, right? So I can multiply this by -1, but it needs to be, that value still needs to be 1. So what can I multiply -1 by to get +1?
-1.
Another -1, right? So this is going to be equal to the integral of x plus 1 times the square root of u, right? Times -1 times -1 times my dx, right? So you notice this part right here, that little piece right there is going to become my
D.
du. This -1 right here I got to deal with, right? How can I deal with that?
Bring it up.
Bring it out. I can bring it out in front. Okay, I got another problem. This x plus 1, right? So what can I do with that one?
Solve for it.
Solve this u equals 2 minus x for
X.
x. Yeah, Roxanne?
And on the first step, you don't want to use parentheses to separate the dx and the
No, you wouldn't have to. I mean, if you want to, it's okay. As long as it stays, it's the same product. Okay. Okay. So this would be u. Okay. You guys know what I do? I move the. Can we do this in our head? I'm going to move the x to the left-hand side to make it positive x, because then I won't have to worry about dividing. All right. And that becomes x equals 2 minus u. So that means this x right here, I can replace with 2 minus u. So this is equal to the integral of 2 minus u plus 1, right? That square root of u becomes u to the 1/2 times -1 times du. At some point, you're going to get everything to be u's and du's, right? You can do it in steps, okay? You don't have to do it all in one step, okay? Okay, so where did this -1, right? I needed that one -1 to make my du.
But what about the other? Yeah. You said you're going to bring it up.
Yeah, so that's what I need to do next, right? And I forgot to bring it out, so I just wrote it here. I forgot to put it here, so I brought it out here. So now what am I going to do? Bring it out in front? Yeah, I just forgot. Okay, and because I still need to clean this up a little bit, right? And okay, this part right here, this x right here became that right there, that 2 minus u, right? And this plus 1 is that plus 1, right? So I'm gonna bring this -1 out in front. Integral of 3 minus u times u to the 1/2. That -1 is gone because I pulled it out, right? And I'm left with just du. Okay, whereas the original problem I couldn't multiply, right? This new problem, I can, right? Because it's just, I gotta take this u to the 1/2. It's just distributive property, right? U to the 1/2 times 3, right? So this becomes -1, the integral of 3u to the 1/2 minus
3 squared.
Gives you 3/2. The 3.
u to the 3/2,
Yes.
and then du. What's that? Okay, so this -1 and this dx made up my
Oh, okay.
du, right? And I'm left over. This -1 is this leftover one that I needed to make the -1 dx, right? And now, okay, this is kind of a simple one to integrate, right? That should always happen. Like it's something that you know how to integrate. Okay, so -1 bracket, or you could also use parentheses. Okay, 3 times, leave yourself some space, u to the 3/2, divide by 3/2, but a better way is to multiply by 2/3, minus, leave yourself some space, u to the
5/2.
5/2, divide by 5/2, better way is to multiply by
2/5.
2/5 plus c. So that's, can I clean it up and distribute the -1 at the same time?
Yes.
So this, okay, 3 times 2/3 becomes
2.
2, but I'm multiplying by -1, so -2. So this becomes negative 2 u to the
3 halves
3 halves, negative 1 times negative 2/5,
plus
positive 2/5, so plus 2/5, u to the
12 halves
5 halves plus c. This u right here gets replaced with 2 minus x, so negative 2 times 2 minus x raised to the 3 halves power plus 2/5 2 minus x raised to the 5 halves power plus c. You know, I didn't say this. This is actually negative 1 times c,
But still
No
C.
minus.
Right?
but still a constant, right? Yeah.
So it's like plus and negative.
Yeah, plus a negative. Yeah, plus something negative, right now. But you don't know C is negative, so it actually could be plus, right? You don't know what C is, right? Everybody good? Yeah? Doing okay? Making sense?
yeah
Am I making it look easy? Okay, that's a mistake, because it's not.
Oh.
No, you know what you're seeing is you're seeing somebody that's been doing this a lot, right, and has a lot of experience. So that's why it looks easy, because like I know what to pick you because I've done so many gosh darn problems with these. Okay, that's what you're seeing though. I got to get you to be like that. All right, all right. It just takes a while. Just be patient. Be patient with yourself. Not beat yourself up when you can't get the right one. Okay. Just try something else. Okay. Don't be afraid to try it. Like, oh man, let's try something else. Okay. Okay. This problem. Okay. So here's an example of you could let u be a lot of things. Okay. I see a square root, right? Yeah. So I might want to make the thing under the square root be my u. So that would be x plus 4. That's a choice, right? I also see this function that's a rational function, right? Maybe I want to make the denominator, the whole denominator, be my u. Because that's a function, right? Reciprocal functions, right? Might be that, right? So you never know. But let's kind of think ahead. If I let u be x plus 4, that would be the square root of u, right? So kind of thinking ahead. Okay, so that'd be the square root of u. And then that could be written as u to the 1/2. That would mean I'm dividing by u to the 1/2, right? So each of these terms in the numerator, could I just divide by u to the 1/2? Like thinking ahead? Does that make sense? And so maybe that might be a good choice. You don't know until you try. So let's try to let u be x plus 4 and see what happens, okay? You understand?
yeah
Okay. So if you make this, if the denominator becomes something really simple, you might be able to divide by it, right? Okay. So let's let u equal x plus 4. That would mean du is equal to
dx
1 dx or just dx, right? So du and dx are the same thing. So that dx right there, boom, pop it out, replace it with du. They're the same. Okay, they are the same if u is x plus 4. Okay, so let's see what happens here, okay? So this is equal to the integral of 2x plus 1, I don't know how to deal with that yet, over, this would be the square root of u, and this would be du. This is really u to the 1/2. Yeah? Okay, now, I can't divide yet, right? Because these are x's and these are u's.
so for
That wouldn't be helpful.
x
So, could I change this and make it become u's?
yes
How? Solve for x, right? So using this one, what is x?
Which is 4.
U minus 4 would have to equal x, right? So that x becomes now, you guys, I should have had equals right there. Okay. And then equals, and this is the integral of 2 times
human
u minus 4 plus 1 all over u to the 1/2 du, and see now it's all u's, right? So the top becomes the integral of 2u minus 8 plus 1 over u to the 1/2 du. That numerator actually becomes 2u minus 7 over u to the 1/2 du. Now this came from adding fractions with a common denominator of u to the 1/2, right?
Yes.
So you can start, doing each one, right? Now that's how what I've been seeing on like tests and stuff is that that's how you guys are handling this situation. Is you divide each one of these by u to the 1/2. Absolutely fine, okay. Do you know another option you could do though? Take 2u minus 7 and multiply, put parentheses around it, and multiply it by u to the negative 1/2. That's a valid way of doing it too. So 2 ways of doing it. Okay, it's kind of your choice. So this, I'm going to do it the way what I've been seeing a lot of you guys do it, and this be 2u over u to the 1/2 minus 7 over u to the 1/2, and then du. This is not ready to integrate though yet, right? What is this power of u right here?
2 over 2.
2 over 2, right? And so when I have this, when I'm dividing, right, I subtract the exponents. So this becomes the integral of 2u to the
1/2.
1/2. This one needs to be rewritten as 7u to the negative 1/2 du, and now it's ready to integrate. So this becomes 2 times, leave yourself some space, u to the 3/2. Divide by 3/2, but better way is to multiply by 2/3 minus 7 u to the 1/2. Divide by 1/2, better way is to multiply by 2, and then plus your c. So this becomes 4/3 u to the 3/2 minus 14 u to the 1/2 plus c. And then replacing your u with x plus 4. And we have our answer. Everybody okay?
We should change the x plus 3 to the 1/2 as that to square root.
No, because u was just simply just x plus 4. It wasn't the square root of x plus 4. Right? It was just the x plus 4 piece. So that u right there is just x plus 4. So that's what I switch it with. Okay? Yeah?
Yep.
Okay. Last problem. You guys don't know how to integrate tan x yet, right? You know how to take the derivative of tan x. The derivative of tan x is,
Secant squared x.
so you know how to integrate secant squared x, tan x, right?
Yeah.
So the problem is there's no derivative that would give you tan x, right?
Yeah.
Right?
Right.
It's because we need integration by substitution. That's why you don't have one. Okay? You need integration by substitution. Okay? Well, what do you substitute, right? Well, we got to rewrite tan x. Tan x can be rewritten with a trig identity as
Sin x over cosine.
sin x over cosine x. Yeah? Okay, what do you think we want to let u be? Do you see, if I let u be this, then I get this derivative that would help me out? Let u be cosine x?
Yeah.
Okay, what's du then?
Negative sin x.
Negative sine x dx. That's helpful. Why? Because this sine x and this dx makes up a part of du, right? What's missing is the,
Negative.
but I can fix that, right?
Yes.
So this is equal to the integral of -1 times -1 sine of x all over cosine x dx. And this part right here becomes what? That's my du, right? This -1, how can I deal with that -1?
Bring it out.
Bring it out. So this is equal to -1, the integral of
1 over u.
1 over u.
Yep.
Because this -1 came out, right? I have 1 over cosine x, but cosine x we said was u, right? So 1 over u. And then this part right here is your, do you recognize that? You should. Natural log, huh?
Yep.
Of the opposite value of u.
U.
Okay, so we have -1 in front though, right? So it becomes negative ln of the absolute value of u plus c. But what's u?
Just cosine x.
So this is negative natural log of the absolute value of cosine of x
Plus C.
plus c. And that's the antiderivative of tan x. See, we needed u substitution to do it. That's why you haven't seen it yet.
Oh.
Okay? So what the heck is the integral of cotangent x dx?
I think I know. Totally like, think about it.
Cosine x over sine x?
U is sine.
Let u be
Sine x.
sine of x. Du would be cosine of x
Yeah.
dx. Man, everything's just right in front of us, huh?
Yeah.
So this is equal to the integral of
1
1 over
U.
u du. That's just ln of the absolute value of u plus c. That's equal to ln of the absolute value of sine x plus c.
Wow.
Crazy, huh? Okay? I'm done. You guys have any questions at all? Okay, so let me tell you. So tomorrow what's going to happen is, okay, we've done all these antiderivative pieces, right? The indefinite integral, which are antiderivatives, right? So what we're going to do next is definite integrals, where we have the numbers here,
Oh.
okay? And I'm going to show you what to do when we have, because you do this u substitution along with a definite integral, okay? Got it? And there's there's going to be an easy way, okay? I'll show you tomorrow. All right? That's tomorrow's lesson. And then we're done with u substitution, okay? And then we got separable differential equations, long division, completing the square, review, and we're done, man. I gotta get those tests done. I'm still not done, sorry. I was hoping to be done like at least today. It's math 2, man. Math 2's weighing me down. It's always something every year. It's like some of the class. This year it's math 2. All right, let me give you the homework and you guys can get started on it. Really just day 1.
Okay.
Yeah.
Wow.